All right, we're streaming.
Do we have notes, or
I found
just
it.
continuing yesterday?
The ones from yesterday. Oh, I thought we finished those.
No.
Is that the intro music?
Or
Oh yeah.
it's just what I started with. I like the applause.
What was the first one?
Oh, by the way, somebody was streaming.
You were streaming.
I was streaming.
Somebody commented.
Okay, I was. They commented on the streaming, and I tweeted their comment.
What was it?
For the very first time, I got called bro.
Can I?
Who was
Can I
it?
check?
Huh?
Can I check?
Well, you could check later once I get started.
Wait,
Here.
Burger. Which? What was the first one?
What was the comment? They like the streaming, but I got to be a little bit more careful on when somebody responds to me. That I got to be able to respond to them, and I don't know what I'm doing wrong because I'm not seeing when people respond. So.
Can I have the notes from yesterday? I printed them off, but I don't think it's on full. Thank you.
I just had the last few to do. Is that correct?
Yeah.
Okay. So we'll do that. Okay. I'll finish these notes. I'll give you time to work. We'll start improper integrals tomorrow, and then we'll finish those up Monday.
When should we expect it next week?
So we will have a quiz Tuesday. So people that are in student council, do we have anything going on Monday?
Dodgeball at night.
Dodgeball at night. So it's a regular class day. What about Tuesday next week?
We have coordination and like the first half of the talent show, I think.
Okay, that's during school.
Yeah.
Okay, so we'll have a modified schedule then.
Yes.
Are they gonna
Okay.
like come out with times for that? Because I'm literally not gonna show up to the school at the right time if like they don't, because I would be service at the middle school. And it's
You know we're streaming right now?
what?
You know we're streaming right now?
Are we?
Yeah.
Cool. Hi guys. I'm always late to class and it's great. Nobody ever tells me anything.
Do a segment on Flora on Kruger's channel of like get to know the people behind it. It's so segment.
Yeah, it has like a fun like boppy intro. And it's like and Jane's like NDSU and Abby's like
What?
Say Sandworm.
So I'm thinking the quiz would be rather short, so I think we could take the quiz on Tuesday. Have review Wednesday, test Thursday. I'm looking at.
Okay. Wait, what do we do on Thursday? Do we not have anything on Thursday?
Thursday we have the
No,
Talent show.
oh yeah.
Friday.
Friday. So Thursday's a good day. You'd have a full time on. What?
Yes. Next Thursday we'd have a full guy.
Yeah. So we'll have the test Thursday next week.
Okay.
Okay. Tomorrow will be a work day. It's a short day anyway.
Can you live stream us like all crying on the test?
Yeah. I can turn this camera around. Okay.
2 hours of crying on Florida.
Okay, I gotta see if I got a button of a baby crying. Alrighty. Did I do number 7 yesterday?
I don't know. I don't know.
Yes. Look.
Yeah, you did.
We're taking limits?
Yeah, we stopped at number 8. We got like halfway through 8.
Okay, I'm gonna restart number 8. I kind of started the right way, and then I just had a brain malfunction. So this is what I'm going to do, and here's the issue. Here's the indeterminate form. If you take the limit of what's inside these parentheses, you're going to get 1. So you have this idea of 1 to infinity. And you would think the answer to that is 1, but it's not. Okay, in fact, this right here, I don't know if you've seen it before. I kind of showed it last year, and I know Mr. Karsh showed it the year before. This is actually a definition of a particular number. And that particular number is E. This is the definition of E. So we should get E as the answer. Okay? But you have this indefinite form. Remember I showed you form of indefinite forms 1 and 2. This is an indefinite form of 1. And this is how we do this, is I'm going to let Y equal 1 plus 1 over x. I'm going to slide that up a little bit better. 1 plus 1 over x to the x power, and I'm going to take the natural log of y, and I'm going to get x times the natural log of 1 plus 1 over x. All right? So that's the first step. And so rather than take the limit of this, I'm going to first take the limit as x goes to infinity of the natural log of y. That's the way I'm approaching it. In other words, I'm taking the limit as x goes to infinity of x times the natural log of 1 plus 1 over x. And I can write it like this. I'm going to get it into that form where I got to have a fraction. So I'm going to have the natural log of 1 plus 1 over x. And down here I'm going to have 1 over x. And if you take a look at this, can I use L'Hopital's rule? Well, I have to look at its form. If x goes to infinity, this fraction right here heads towards 0, correct? And 1 plus 0 is 1, and the natural log of 1 is what? No. It's 0, because e to the 0 gives you 1. And as x increases here, that also heads to 0. So I have an indeterminate form of, which is in terms of a fraction, where now I can apply L'Hopital's rule. And if I apply L'Hopital's rule, I'm going to get this. First of all, the derivative of a logarithm is 1 over x plus 1, and then the derivative of this on top. Do you remember that? So what would be the derivative of this? Well, the derivative of 1 is what? 0. The derivative of this is what? Negative x to what power? Negative 2, correct? So I could write it like this, and you're okay? And the derivative of this is what? I'm taking the derivative of this now. The derivative of the natural log is this, and the derivative of 1 over x is going to be negative 1 over x squared. Which means now I have the limit as x goes to infinity.
Kruger, that x needs to be squared.
Yep, thank you. Is a negative 1 over x squared over 1 plus 1 over x divided by a negative 1 over x squared over 1, right? Because that's what I'm dividing by. Are we okay with that?
Yes.
Okay. So this gives me the limit as x goes to infinity of 1 over 1 plus 1 over x. What is that limit? One. So that means that the limit as x goes to infinity of the natural log of y equals 1. Well, that means e, because that's the base of the natural log, of 1 equals y. So if I come up here and I say, well, I'm taking the limit of this, this right here is taking the limit as x goes to infinity of y. What does that have to be? E. Okay, we're going to do this process again. So the answer to this is E, because that's what E is, that's what y is. So I first take the derivative of the natural log, or take the limit of the natural log, and so if that's true, that means that's what that exponent is going to be. Well, what is y going to be if that exponent is going to be that? It's going to be E. So let's take a look at this one. Same type of idea. I'm going to let y equal the sine of x to the x power. Now, if I do this, I'm going to just see what type of form it is. If I plug 0 into sine, I would get 0, because the sine of 0 is 0, and raised to the 0 power is 0. So that's the form that I have, and I cannot use L'Hopital's rule when it's in that form. It's got to be in the form of a fraction. So what I'm going to do is the same process. Because my variable is in an exponent, I'm going to take the natural log of both sides. So I'm going to have I'm going to have x times the natural log of the sine of x. And I'm going to take the limit of this natural, I'm going to take the limit of the natural log of y. So this is what I'm changing this to. Or I could say that's the same as taking the limit as x goes to infinity of x times the natural log of the sine of x.
Infinity as opposed to like 0.
Pardon?
Why would it be infinity?
It should be going to 0 on the right. All right, so that means when I take this limit, I can write this as the natural log of the sine of x over 1 over x. So let's see what indeterminate form it is. I'm approaching 0 from the right. Jaden, give me a number that's to the right.
1.
1, okay? Now I'm moving closer to 0, correct? Give me another number that's closer to 0 from the right, that's closer than 1.
0.5.
Okay, so now I'm dividing by 1 over 0.5, right? Correct?
Yes.
And so give me one that's closer than 0.5.
0.25.
0.25. So now I have 1 over 1/4, correct?
Correct.
That's 4. Okay, give me one that's closer.
0.2.
0.2, okay? So now that's 1/5,
Correct.
right? 2/10, 1/5. So now it's 5. So every time you give me a smaller number, what's happening to this what's happening underneath this fraction? It's getting
Bigger.
bigger, right? So where is it headed?
To infinity.
To positive infinity, right? To infinity. So now, if I take and look at the sign and I get closer to 0 on the right, where is this headed? Well, do you guys remember what the natural log curve looks like? It looks like this. So as I'm headed towards 0, where is the natural log headed? Negative infinity. So now I have it in the indeterminate form that I want, that I can use L'Hopital's rule. In other words, I can write this as the limit as x goes to to 0 on the right. So what is the derivative of the sine of x? Well, what's on the bottom? The sine of x. What's on top? Cosine of x. Because the natural log, it's that function on the denominator with its derivative in the numerator. what's the derivative of 1 over x? Well, we've done that a couple of times. It's negative 1 over x squared. What does that give me? Well, this gives me the limit as x goes to 0 on the right. This is cotangent of x over negative 1 over x squared. We all right on that? Which is equal to this. The limit as x goes to 0 on the right. This is going to be a negative x squared over tangent x. Are we all right there?
Did you just flip them?
Right, because cotangent is the reciprocal of tangent, and I can multiply by the reciprocal of this, which is a negative x squared. Okay? So now, I'm going to take a look and see if I can take the limit here. Well, as I approach 0 from the right, what's happening up in the numerator? Is it going to negative infinity? It's going to 0. Does everybody see that's going to 0? It's getting really small. And what happens when I approach tangent? Do you remember the tangent curve? It looks like this. Right? So as it's headed to 0 also, isn't it? So that means now I can take the limit again. And I get a negative 2x. What do I get on the bottom? Secant squared. So if I approach 0 here, I could plug 0 in here and get 0, right? What do I get here? Well, secant is the reciprocal of what? Cosine. The cosine of 0 is 1. So the secant of 0 is 1, right? Because the reciprocal of 1 is 1. 1 squared is, so I get 0 over 1. So this limit, the limit as x approaches 0 to the right of the natural log of y is going to equal 0. So that means the limit, and this could be rewritten as e to the 0 is equal to y, correct? So that means the limit as x approaches 0 to the right of y has to be what number? 1.
Can you explain how you got there?
All right. So the whole process is when I have something in this form, it's impossible to get it as a fraction. So I have to create another form to do that. The form that I create is using a logarithm. I choose natural log because we know we can take the derivative nicely of natural log. That's why I choose it. The derivative of natural log is whatever the function is as the denominator and its derivative as a numerator. I get a fraction right away. Okay? So I go through the process not to determine what the limit of y is right away, but what the natural log of y is. And if the limit of the natural log of y, if the exponent of e is headed to a certain place, well, that means y has to be headed to wherever. This is what I'm doing. Let's look at it this way. If I have this, where would you say that's headed?
No.
It's headed to 1, isn't it?
Yeah.
Because e to the 0 power is 1.
Yeah.
Okay? If I know this, that the limit as x approaches 0 from the right of the natural log of y is 0, okay, what I'm saying here is, what is y? Well, y is e to the x, isn't it? Well, if that's headed towards 0, doesn't that have to be headed towards 1?
Yeah.
Okay, and that's why this is headed towards 1.
Okay.
Okay? All right, so let's take a look at this one. Again, if I take a look at this form, what I have in here, if I plug this in, I have 1 over 0 minus 1 over 0, right? I have something crazy that I can't figure out. So I want to get it in the form that I want. So I'm going to get a common denominator. And the common denominator is the product of these two denominators. Would you agree? So I'm going to get x minus 1 minus the natural log of x over x minus 1 times the natural log of x. And I'm going to pause there. And does everybody see how I figured that out? We're okay with that? Now I want to see what form it is. I always must see what form it is to be able to use L'Hopital's rule. I have to have 0 over 0, infinity over infinity, some form like that. So if I plug 1 in there, I get 1 minus the natural log of 1 over 1 minus 1 times the natural log of 1, and I think you can see I get 0 over 0. So I'm going to take the derivative. Taurus, how you doing?
Great.
Okay, you want to take the derivative of the numerator or the denominator? Well, one's a little bit easier than the other. Huh? Denominator. What rule are you going to have to use? Product rule. So you got x minus 1 times what? 1 over x. Plus the natural log of x times what? 1. I'm going to do the top. Okay. The derivative of this is 1. Derivative of this is 0. Derivative of this is minus 1 over x. I thought you would choose that for sure. Okay, so now I'm going to rewrite this. I get the limit as x approaches 1 from the right. And I'm going to write this first of all as x minus 1 over x. And this one I'm going to write as 1 minus 1 over x plus the ln of x, and I'm going to write it one more time. As x minus 1 over x, and here I'm going to have x minus 1 plus x times the natural log of x all over x. Did everybody see what I did there? So I said the common denominator here is x. This is x over x. This is x times the ln of x over x. Hi, how you doing? You know you're in the abyss right now? You feeling okay?
He's live streaming.
Yeah.
He's live streaming.
They missed us the end.
Are you getting nervous?
No.
No, okay. You know what? I want you to relax a little bit more. Okay. Emma, I got mail for you.
What?
I got mail for you.
You've got mail.
There you go. And the reason I write it like this is now it's going to look like the limit as x approaches 1 from the right of x minus 1 over x minus 1 plus x times the ln of x. Slide that down.
Are these questions considered hard, or are these just normal questions?
What?
Are these questions hard, or are they just normal questions?
These are a little bit more challenging. Okay?
Like,
Will this one be on the test?
maybe.
I would say there won't be on the test, but like number 8 could be on a quiz. Okay?
That's true.
Okay.
So now I'm going to put 1 in here, and I'm going to have 0 over 1 minus 1 plus 1 times the ln of 1, and you can see I get 0 over 0. Right?
Yes.
Okay? So that means I can do L'Hopital's rule one more time. And, Emma, what's the derivative of the numerator? 1. What's the derivative of the denominator? Jonathan. What's the x going to become? 1. What's the minus 1 going to become? What are you going to do here? Okay, what is it? Plus what? X times 1 over x plus the ln of x times 1. So I'm going to scoot on this page and take a look at the limit as x approaches 1 from the right, and I have 1 over 1 plus 1 plus the ln of x. I cannot do L'Hopital's rule anymore, can I? What's my answer? Well, I got 1 plus 1 plus the ln of 1. I get what is my answer? 1/2. All right. Okay, super. And
Wait, so is that where you end then?
yeah,
Why did you not do the?
I did not do a natural log at all this whole time.
Okay. Oh.
Okay, it was a different type of problem.
Okay.
Okay. All right, I'm gonna stop streaming right here. I hope you guys have a pleasant day. I got a feeling I got a lot of questions, but I haven't figured out how to see them. So I'll get that figured out maybe by tomorrow.